Okay, so we would like to show this identity by Euler, and let's also notice that this is equivalent. Just replace x by negative x with this identity. Depending on the context, one might want to use one or the other. So let's just give both. And also please note that for n equals 0, the product on the denominator is actually just 1. So you literally get 1 for the whole term. Okay, so let's prove this identity. And we will work with the one in blue. So the idea is pretty straightforward. So it's actually derived by looking carefully at the coefficient. So let's define the function f of qx to be the left-hand side. And of course, it can be written in the form sum from n equals 0 to infinity of some polynomials un of q times x to the n. And pretty much the point of the proof is to show that this polynomial is exactly this expression up here. So which is actually not just a polynomial. This is actually a series in Q, which is what that is going to be. So in other words, by taking this product right here, it will be possible to obtain x to the n in infinitely many ways, which means that eventually this should be considered as a series. So this is a series in Q. Okay, so having said all this, let's just notice the following very simple identity, that f of q comma x is nothing else but let's just write it out. I think this is the easiest way to make the point that I will try to make. Okay, and basically what I'm going to argue here is that we can separate the first term, and then we can view everything else as 1 minus q times qx times 1 minus q squared times qx, 1 minus q cubed times qx, and so on, which of course implies that what we have here in the bracket is pretty much the same function, where x is replaced by qx. Okay. So once we understand that, then we can write out the corresponding series. So this is what we get on the left, and on the right, I will just write this. Oops, sorry about this. And then sum from n equals 0 to infinity of un of q times q to the n times x to the n. And now the idea is very simple. Let's just look at both sides and see what is sitting in front of x to the n on both sides. So on the left, we simply have un of q. Now, what do we have on the right? On the right, we will have two series. One that we get by multiplying one with this series. And of course, what will be sitting in front of x to the n is going to be simply un of q times q to the n. And then we're going to have another one. And what is going to be sitting in front of q to the n, in front of x to the n, is, since you have an extra x here, then you have to look at the term for the previous term that had an x to the n minus 1 here. And that would be un minus 1 of q times q to the n minus 1. And we will also have a q that comes from here. Okay, so that's exactly what we will have. And now what we can do is just bring this on the left. So that will give us un of q times 1 minus q to the n is equal to minus q to the n un minus 1 of q, which gives un of q is equal to minus q to the n over 1 minus q to the n times un minus 1q. Now you understand what is happening. Pretty much we will be applying this identity over and over. So we will get, for example, let's do one more step, q to the n over 1 minus q to the n times minus q to the n minus 1 over 1 minus q to the n minus 1 times u n minus 2 of q. And pretty much we will be applying this till we get down to u sub 0. So this will be minus q to the n over 1 minus q to the n minus q to the n minus 1 over 1 minus q to the n minus 1, all the way down to minus q over 1 minus q times u naught of q. And of course, u naught of q is 1. This thing is 1, simply because we can go to the original expression and ask ourselves when exactly we get 0th power, and that's exactly when we multiply the number 1 from each parenthesis. So the bottom line is that if we tidy up this a little, that will give us negative 1 to the n, because we have n negative 1s in those parentheses. Then we will have q to the sum of all these exponents. And that's again the sum of all numbers from 1 to n, which is n times n plus 1 over 2. And on the bottom, we will have 1 minus q. I would write them the other way around, 1 minus q squared, all the way to 1 minus q to the n. Okay, so that's un sub q, which is precisely what we wanted to show. So this establishes our identity. And that's all. Thanks for watching.